This session, I'm going to talk about some of the enhancements that have been made in the REST client in the various 2019 releases. First of all, we have our legal disclaimer, and let's go over the agenda. So, in case people aren't familiar with who I am, I was going to introduce myself for a little bit. But then we'll cover the RetrieveOne method. The initial REST client had a retrieve method that's still there, that retrieves all the rows. But this new retrieve method, one method, is for retrieving a single row. There's been a submit method added. In the original version of the REST client, you would send data to the REST service, but then you have to make a second call to get data back. And what the submit method does is it sends the data and gets the result, retrieves the response data back in a single call. The SetRequestHeader method, the behavior there that has been modified a little bit. There's been functionality added to do Gzip compression automatically. There has been features added in order to get and set OAuth tokens and JWT tokens. And then there's a number of new methods that all have the send HTTP verb request as the name. So these are the verbs: get, put, post, patch, and delete. So there's a send get request, send put request, send post request. In some of these other methods, you would pass in the HTTP verb as an argument, but here it's actually part of the method name. And then we'll have a demo of some of these new features. So first, a little bit about me. My name is Bruce Armstrong. I work for a company called Integrated Data Services. Started there in 2004. Prior to that, I spent 15 years doing independent contracting as a PowerBuilder developer. When I started with IDS, they were a client-server shop doing PowerBuilder development as an ISV. We've actually since migrated most of our applications over to HTML5 JavaScript with Java in the middle tier. But we still have a couple customers that are still using the PowerBuilder client. In addition to PowerBuilder, I'm pretty fluent in Oracle PL SQL, Java, C#, as well as C++. And I'm involved in a few open source projects that are might be of interest to PowerBuilder developers. One is the open source PFC libraries. I help maintain that. I wrote a utility called PBNI SMTP that uses the PowerBuilder native interface. So it's a C# DLL that acts as an extension to PowerBuilder and allows you to send email via SMTP. And then I've created a plugin for Jenkins. Actually, several plugins for Jenkins, but the one of probably more interest to PowerBuilder developers is the one that uses the autocompile utility that was introduced in PowerBuilder 2017 and is still available in 2019 to do automatic compiles, so that you can do automatic compiles using Jenkins. So if you're looking to move into continuous integration and using Jenkins to do builds, that's something you might want to look at. A little bit about the company I work for. Okay, let's get into the enhancements. So there's a RetrieveOne method, as I mentioned, similar to retrieve, but it only returns one row. If the result set contains more than one row, only one row is added to the data window. So this is an example of what it looks like calling it. Create your REST client, call RetrieveOne, you pass in your data window, and the URL you're calling. This JSON placeholder is a publicly accessible REST service. It's basically a test REST web service. It supports sending updates, but it doesn't actually update the data. So you're always consistently getting the same data back whenever you call the method. I like to use it in my demos because I can give you some sample code then, and you can go out there and run it, and it will just hit that REST service. You don't have to create a REST service to use the demo. The submit method can send data from a data store, a data window, or a JSON package. It only uses the post method. So here's some examples or the different variations of how you can call it. I'm just going to get everything on the screen here. Okay, so what you'll see in common here is the URL, obviously the REST service you're calling. You're not passing a verb because this only uses post. The next argument is the response string. So you pass in a string by reference, and whatever the response is from that REST service, that's what's going to come back in that variable. For the first four options here, what you have is DW control. That means either data store or data window that you can pass in. And then this Boolean format, that indicates whether or not you're going to be passing data window JSON or plain JSON. The data window JSON is the one that's specific to PowerBuilder. It contains all kinds of state information, what rows were updated, what columns were updated, what were the original values, what are the updated values. That makes it great for working with the data window, but it's not interoperable. If you pass plain JSON, that means you're sending JSON that's just the data, just the name, value, pairs, arrays, structures. But that's more for interoperability, where you've got other clients or you got a REST service that's not PowerBuilder based and that you want to interact with. Okay. In a couple of these other variations, you can actually specify the buffer that you want to pull the data, send the data from. This would only work if you're going to send it from one buffer. If you're going to send it from several buffers, then this next version works for you better, because now there's Boolean flags indicating what data window buffers that you're going to send the data out of, and each of those have that Boolean format flag as well. This one also has Boolean changed only. So if you've retrieved 1,000 rows and the user only changed one, you don't send all 1,000 rows back. You just send back the one row that actually got modified. And then this fourth version down here, that actually allows you to specify starting row, ending row, starting column and ending column out of the data window buffer. The last one is the one that sends it out of the JSON package. So you've put some JSON together manually, and you want to send that JSON in as the data, the payload of the call. So you just say URL name, your response string by reference, and then you just reference the package, and this method will actually pull the JSON out of the JSON package and send it. And so here's an example of using the submit method. Once again, I'm using the JSON placeholder, and I'm sending, what I've done in the previous step is pulled data into a data window. Supposedly I've modified some of this data, and I send it back. So I'm sending the data window, I'm sending out the primary buffer. I'm using the, looks like what I'm using here is the version that allows me to set the start and end row. So I just set it to 1 and 1, so it just sends the one row. And we can see what the response is from the service, because I pull that string that I passed in by reference and display it in a message box. SetRequestHeader. The problem that we had with the original SetRequestHeader is that if for some reason in your code you called it multiple times for the same header, it would just keep adding it over and over again. So that has been addressed now through this. It's an optional argument. For backwards compatibility, the default is false. So if you don't provide it, it acts like the original implementation, where if you call it 3 times, it will add the header to the request header 3 times to the request 3 times. It will appear 3 times in the request. If you say true, which is not the default, then if the value already exists in the request, it will just replace it rather than add it on again. So for Gzip, what happens? This is pretty much automatic. If the data but what PowerBuilder does is it looks at this data as it's coming in and determines if it's in Gzip format. And if it is, it will automatically do the decompression for you. So there's nothing you really need to do to handle the Gzip compression. It comes along automatically. the way you get the data in Gzip format is you set an accept encoding header to Gzip in your request to the service. Now that doesn't automatically mean you'll get the data in Gzip. That just means if the service supports doing that, it will send the data in Gzip. If it not, then you'll just get back in JSON anyway. So this is an example, some sample code, and I've got, this is part of the demo here, where I'm calling the water services REST service of USGS, which is a big block of data. And I toggle between whether or not this header is set, which tells the service to put it in Gzip or not. What this primarily does, by compressing the data, it transfers faster, but then it has to be encoded on the server side and decoded on the client side. It's not. It does usually give you a performance benefit, but you just need to be aware that there's some additional work that has to be done, not by you, but by the client and the server in order to make the Gzip happen. And this is an example, okay? So, and this is actually with the web service I was calling in that sample code there. So, what you see here, and this is kind of the point I was trying to get to. The body, if it was just plain JSON, would be 523K. The body after compression is only 18.5K. So it is hugely smaller. But if you look at the overall elapsed time, it's 1.4 seconds versus 0.7.8 seconds. It's not you would expect that if the body was this much smaller, the transmission speed would be correspondingly smaller, and it doesn't quite work out one-to-one there. It is faster. It's not quite as fast. It's faster, but it's not as fast as you necessarily would expect because of the size of the data, because of that additional overhead of the compression on the server side and the decompression on the PowerBuilder side. So next is OAuth. So there's a couple new methods here. Let me get them all on the screen. So there is a get OAuth token and a set OAuth token. So what you do is you prepare a token request, and then you pass in a string by reference, and you get the token back. So that means this is in the case where the server has provided you with a URL that you call to get your OAuth token, and then you include that in all subsequent requests. So what the set OAuth token does is it takes the REST client and says every call you make from now on, once I've passed you this OAuth token, send that in the request header. Generally what happens with a service, if they've got one entry point where the OAuth token isn't required, and that's the one where you essentially log into the service and get the token, and then everything else behind that is behind the authentication, where it won't let you in unless you do provide the OAuth token. So this is an example of doing that using Twitter. So this is the URL that Twitter gives you so that you can request an OAuth token. I found that if I didn't put in some kind of user agent, Twitter would actually block the request. So that's why I've added that down there. And so then you do your get token request call and get the access token, and I just display it. And then what I do is I put together the actual call I want to make now. I do the set OAuth token and then send my request. Now you only have to do this step, the set OAuth token, once. And from then on, it will just continue to use that token. You don't have to do it before every call. Okay. So the next item is JSON Web Token. That's an alternative to the OAuth token. And I'm just going to cover a little bit of what the JSON Web Token is. There's three pieces. There's a header. You see it up here. What that indicates, it's all in JSON, but what the header piece indicates is what algorithm is being used to sign the token. And then this type is, I've never seen anything other than JWT there. Then there's a payload, that's this section down here, that indicates who the user is and what roles you're claiming they have, and then how long the token is good for. And then down here, this is notice we're signing it. This is the signature information. So the header and the payload are both base64 URL encoded. They're concatenated with a period between them. You actually see that here on the left side. So this portion in red. This is the header, base64 encoded. This area in purple is the payload, base64 encoded. Then that portion, the red and purple portion, are then signed, and then that information is added on as the last part, the signature. So you send that in your REST service, in the REST call for the OAuth token, and you get back what's called a bearer token. And the bearer token generally is what you send back on the request. There's actually a few different scenarios here. I mean, I've worked with a lot of REST web services, and when you talk about JWT authentication, there's a couple different flavors here. So this is one of the flavors. This is what these PowerBuilder methods for the REST client were designed to support. The idea is that you pass in like a user ID and password to the REST application. It generates a JSON Web Token. The bearer token is sent back, and then you add the bearer token to each request that you send after that. So if that's the way the service is configured, you're going to be able to call it from PowerBuilder fine. It's primarily used when you're doing internal applications. I don't see a whole lot of third-party services that actually use this approach. This is what I call scenario 2. I didn't have real good names for these different scenarios, but this is what I typically see more with third-party web services. Is that you put together the JSON Web Token yourself, making claims about who the user is, and you pass that to the REST application, and it sends back the bearer token. You're not doing a login so much. And then this is the third scenario, and I've got examples of all three of these in the demo, including calling them from PowerBuilder. Incidentally, scenario 2 is used by DocuSign. There's one example. Scenario 3 here is used by the Sailing Group. At least that's what I base my demo on. What they do, they've got this. The issue that they have with JSON Web Tokens is that they have a lifetime. So you say it's good for like 15 minutes or whatever. They're concerned that somebody, you get a man-in-the-middle attack who will get your bearer token and then start doing their own requests using your bearer token. So they don't ever send a bearer token. What they do is they make you send the JSON Web Token. You put together the JSON Web Token and you send it with every single request, and they validate it on every request, and then if it validates, send you the data back. And if you're wondering, I kind of skipped over that part, how the service knows whether or not you're actually the user. It comes in the encryption of the JSON Web Token. They give you, you work with a public key, private key. So you've got a private key, and you use that for the encryption of the JSON Web Token. And when it's sent then to the server, they've got the public key, and they can determine, yes, because you encrypted it using your private key, you are that user. So that's why you don't have the login. Okay, so this is what I was mentioning earlier. This get JWT token and set JWT token methods only support that first scenario. You can do scenario 2 and 3 with the REST client, but you need to do the work of actually creating the JSON Web Token yourself. And I've got the sample code I'm going to show you here a little bit later. It shows you how to do that. And if you're doing with snap develop, the sample code that I've got for snap develop shows you how to respond, to handle the token request and send back the bearer token. And like I said, I've got examples for scenario 2 and scenario 3 as well. So this is what that call looks like. So once again, this is scenario 1. So you're taking a username and password, and you're putting it together as a JSON payload, and then you're sending it into the login request and getting the token back by reference. And then you set, just like with the OAuth token, you do a set JWT token, and that token's then sent on every subsequent request. So now the send bracket HTTP verb name close bracket request methods. Here's the difference again, is that in the original methods that were put on the REST client, you would send data in one call and then retrieve data in another call. And now with these new methods, you don't have to do that. You can send the data and get the response in a single call. But unlike the submit method, which only does post, these methods support all the different HTTP verbs. As I just mentioned, submit's limited to post. And then the HTTP client is the one where you have the send request, and then you have, too fast. You have this. You send the data, but then you have to use the another method to actually retrieve it. So now with the REST client and with these 5 different methods, you can do it all in one call. So this is what it looks like. Now the main difference here, you see that in your get, you pass a URL name, and that includes any arguments in your URL, and you pass in a string for the response. On the next methods, there's this data argument. So post has data argument, patch, put. They all have data arguments. The reason you don't have that for get is it has to do with the nature of an HTTP call, get call. There's no data passed in a get call. The only way you can pass data into a REST method is if you use post, patch, or put, or delete. Although delete usually doesn't send data, so that's why that one's optional down there. But post, patch, and put, generally you do send data. If you think of it in terms of CRUD operations, create, retrieve, update, and delete, what you often see, you see one of two things. Either gets are used for retrieve and posts are used for all updates. That's one way people do it. Well, the other thing I've seen is you use get for retrieve, use delete for delete, use post for updates, and you use either patch or put, or maybe even post for inserts. So you really need to just kind of work with the REST service that you're trying to access to determine what their particular methodology is. So this is that call to the water services at USGS, and so we do a send get request. All the arguments, if there's any data at all being sent in the arguments of the URL itself, that's the only way you can send any kind of data. And we get the response back. Okay, before I launch into the last piece here, let's go ahead and look at the demos. Okay, so here I have my REST samples. This first one, you saw the sample code for this in the slides. This retrieves the data from the JSON placeholder service. So that's the original retrieve method. Then that does the RetrieveOne, and the submit method actually sends a create. In the sample here sends a create record method call, and so what I get back from that call is the ID number that was assigned to the new record. Although it doesn't actually do it. If you do this and look down, there's no 101, but that's because the placeholder service doesn't actually do the update. It just does it in a mock manner. Okay, so this is the HTTP client. Actually, there's not much different there. Let's skip over here. OAuth. Okay, so this is where I'm requesting an access token from Twitter. This is the bearer token I got back. Okay. And now I can search on, let's say, #PowerBuilder. This is the raw response I got back from that call. You'd have to parse that out. It's a bunch of JSON. But that's Twitter returning all the tweets that reference #PowerBuilder in them. Next we have JSON Web Tokens. Now I mentioned in this session what I called Scenario 1, Scenario 2, Scenario 3. I don't have really good names for the different approaches here, but here's 3 different examples. AirMap follows what I call Scenario 1. Let me show it to you here real quick. By the way, AirMap is a service that if you fly drones, you register your flight information on the path you want to fly your drone in, and what it will do is it will tell you whether or not you're trying to fly your drone through any restricted airspace. So what I do here is I'm going to pass in not a JSON Web Token. I'm passing in a username, password, and some other information that you would normally put in a JSON Web Token. The JSON Web Token's put together on the service, in the service, and then is consumed inside the service, and what we get back is the bearer token. So we don't actually see the JSON Web Token from the client. It's all being done in the service. This is the way that most, where a lot of ASP.NET web services operate. If you go through the examples that they give you for Snap Develop and Snap Develop, that's the kind of JSON Web Token authorization you'll end up generating. And it's what's actually built into the REST client. The REST client natively supports this. And I'll go ahead and send a data request to AirMap. And what I did, just to make it simple, is I just asked for my own account information back. And you had to be authenticated to actually access that. Some of those calls you don't have to authenticate, but for getting your own account information you do. So that is Scenario 1, where the JSON Web Token isn't actually generated in the client. It's generated in the service, consumed in the service. The DocuSign is a, most people I think are already familiar with DocuSign. It's for, particularly in the age of COVID, where people can't meet to sign documents. It's how you email each other and get authentication, get signatures on documents electronically. Now the way you have to do this, first of all, you have to actually request information from the user to be able to sign on their behalf. And so I use the new web browser control here to launch into DocuSign, and once they log in, it will ask them if they want to go ahead and authorize this application to do sign in on their behalf. I've already done that though. So I'll generate the request here. Now this is a JSON Web Token here. So here's the header, which just has the type and the algorithm being used. Now in this case, they're using there's a couple major different algorithms you use. One is just hashing the signature, and one is using asymmetric signing. For DocuSign, they use asymmetric signing. That's part of what keeps it so secure. Here's the body where I've indicated that I want to, which account I want to do signatures for. And this is the JSON Web Token that I've generated using in PowerBuilder. I did have to use, I created a third part, well, I created my own DLL to do the RSA SHA-256 encryption, because PowerBuilder currently doesn't do that with the crypto object. And it's all provided in this sample code, which is going to be available on Code Exchange. But that's a JSON Web Token. You can not necessarily, it's not necessarily easy to see here, but there's three pieces. There's the hashed header, the hashed body, and then the signature down here at the bottom. We send that to DocuSign. They send us back an access token. At that point, PowerBuilder can use this. It's just another bearer token. We can use the SetJWT token to put that on the REST client, and then go ahead and get our data. So once again, like with the error map, I just returned my own account information back. Okay, and then this is the third one. This is the Saling Group. The Saling is a Danish retail chain, although they operate stores in Germany and Poland as well, and they were operating for a while in the UK and in Sweden, I believe. So big grocery chain. Now what they do is this is the JSON Web Token. This one uses the hashing rather than the encryption for the signature, so it's a bit shorter. You actually see the period mark there. This is the hash signature there. But what they do, what their method of security is that they don't trust a bearer token for multiple calls. With these two services, the Scenario 1 and Scenario 2, once you got a bearer token, you can just keep using that bearer token over and over again for whatever the life of the bearer token is. With Saling Group, what they said is we're not going to issue you a bearer. We're going to make you pass us the JSON Web Token with every call. So what we aren't going to send a bearer token. What we're actually going to do is send the JWT in with our data request. And once we do that, this absolutely is a list of some of their stores, and where they're located, what their hours are, all kinds of information about all their different stores. So that's JSON Web Tokens. Okay, and lastly, here's Gzip. Okay, so we got the data back in 2.3 seconds that way, and I'm going to try it with Gzip off, and 2.5, 2.7 seconds. So it's a little faster. It all depends on what your network connection's like. You know, it can save the bandwidth, but you know, like I said, there's parsing time involved as well. Okay, and so that's it. Going back to the slides. One thing I would note, of all the resources on this page, community.appeon.com, if you're not already familiar with it, I think most people know about it because of the Q&A forums there, but there's also tech articles and videos, but there's also code examples, and the code examples I just showed are on that site so that you can actually pull down the code and go through it yourself at your leisure. And with that, I thank you for your attention and hope you enjoy the rest of Elevate 2020.